So good evening everybody. I am going to take the support vector machine algorithm part 2. Okay. Still now we have seen the various support vector machine algorithm in part 1. Let us see what is the basic concept behind this support vector machine algorithm. Okay. So the basic concept is what it is used to find the hyperplane that best separate the data points of different classes in a high dimensional space. The goal is used to maximize the margin between the classes, which is the distance between the hyperplane and the nearest data points from either classes. Okay. And second step is what mathematical formulation we already seen. In the n-dimensional space, the hyperplane is a fat affine substance of dimension. And the third one is what kernel trick we have already seen. There are two types of kernel: linear kernel, polynomial kernel, and radial basis function kernel and sigmoid kernel. Okay, so again we have seen the next steps in this part 2. That is what this here hyperplane, this positive hyperplane and negative hyperplane, the maximum margin, everything is present. So in the fourth point is what soft margin and regularization, which is very important point in the support vector machine algorithm. In the real world scenarios, the perfect separation is often impracticable due to noise and overlapping classes. Okay, to handle this, SVM introduced a soft margin. Okay, soft margin allows some misclassifications by introducing a slack variables. Okay, the objective is to balance maximizing the margin with minimizing the classification error. Regularization parameter controls the trade-off between the maximizing the margin and minimizing the classification errors. A high CC value prioritizes classification accuracy, while the low CC values allow a low margin violations. Okay, this is what soft margin and regularization. We have some noise present in this waveform, right? Our images, right? Overlapping some images, right? We need to do this perfect separation, which is often impracticable due to noise and overlapping classes. There are two types of margin: soft margin and regularization. Okay. Next one is what? The fifth step is what? Support vector machine for regression. Support vector regression extends the regression problems. Okay. It aims to find the function that deviates from the actual observed values by a margin of E while being as flat as possible. Okay. This is what support vector machine for regression. Next one, training and complexity. Training complexity of SVM is generally a quadratic with respect to the number of samples, makes it less scalable to a very large data sets. Okay. And next one is what? Prediction complexity. One trained prediction is efficient and linear with respect to the number of support vectors. Okay. Training and complexity. The training complexity of XML is generally quadratic with respect to the number of samples, makes it less scalable to a very large data sets. Okay. Next one is what? Applications. Support vector machine are widely used in text classification, image recognition, bioinformatics and other fields where the classification takes are prominent. Okay. This ability to handle the high dimensional space and their robustness to overfitting, especially with kernel trick, make them versatile tools in machine learning. Okay. This is what the applications in support vector machine algorithms. Okay. Support machine methods are widely used in text classification, image recognition and bioinformatics and other fields where the classification stakes are prominent. Okay. So finally I conclude that there are 7 steps behind the support vector machine. Number 1 is what? Basic concept. Number 2 is what? Mathematical calculation. Number 3 is what? Kernel trick. Number 4 is what? Soft margin, which is used to perfect separation is often impracticable due to the noise and overlapping classes. And fifth one is what? Support vector machine for regression. And sixth one is what? Training and complexity, prediction complexity and training complexity. At last, applications. Okay. So it can be used in variety of applications, space navigation, bioinformatics and classifications, etc. So thank you all. Let us see the various algorithm in the next slide.